NVIDIA has just unveiled something that could make humanoid robot development much more accessible for researchers around the world. The company introduced the NVIDIA Isaac GR00T, reference humanoid robot, describing it as the first open humanoid robot reference design built on NVIDIA's Jetson Thor computing platform and the Isaac GR00T development ecosystem. One of the biggest challenges in humanoid robotics today is that researchers often have to piece together hardware, software, simulation tools, training systems, and deployment workflows from multiple sources. NVIDIA wants to simplify that process by bringing everything together into one integrated platform that can help researchers move faster from building a robot to teaching it real-world skills. The Isaac GR00T reference, humanoid robot, combines a Unitree H2+ humanoid robot with advanced Sharpa-Wave 5-finger tactile hands, creating a highly capable robotic body. Powering the robot's brain is NVIDIA's Jetson Thor onboard computing system, along with the company's Isaac GR00T software platform. The goal is to provide a complete package that allows teams to focus more on research and innovation instead of spending time integrating different technologies. According to NVIDIA CEO Jensen Huang, humanoid robots could eventually bring physical AI into some of the world's largest industries, creating a massive economic opportunity. He says this new platform is designed to give researchers a single open system that can accelerate progress toward general-purpose robotic intelligence. The robot itself is impressive from a hardware standpoint. It stands nearly 6 feet tall, weighs around 150 pounds, and features 31 degrees of freedom across its body. The addition of 2 dexterous 5-finger hands increases the total to 75 degrees of freedom, allowing the robot to perform more complex manipulation tasks. To help it understand and interact with the world, the robot includes a range of sensors. These include a head-mounted stereo camera with a wide field of view, wrist-mounted cameras for close-up object handling, and motion-tracking sensors that help monitor movement and balance. The machine is also designed for demanding physical tasks, with powerful joints capable of delivering significant torque for lifting, reaching, and movement. At the heart of the system is NVIDIA's Jetson AGX Thor T5000 computer. It features a Blackwell GPU capable of delivering over 2,000 FP4 teraflops of AI performance, along with a 14-core ARM CPU and 128 gigabytes of unified memory. This allows the robot to process sensor data and run AI models in real time directly on the machine. The robot supports a variety of connectivity options, including Ethernet, Wi-Fi 6, Bluetooth, and USB. It also includes microphones and speakers for voice interaction, a battery that can provide around 3 hours of operation, and a remote emergency stop function for added safety. On the software side, NVIDIA is providing a full development platform through Isaac GR00T. Researchers can collect training data using Isaac Teleop, build intelligent behaviors using Isaac GR00T foundation models, and use Isaac Sim and Isaac Lab to train and test robots in virtual environments before deploying them in the real world. Once ready, developers can move those trained skills onto physical robots using NVIDIA's robotic software tools and run them directly on Jetson Thor hardware. A key advantage of the platform is its modular design. Teams can use the entire system or integrate only the parts they need into their existing workflows. This flexibility could help researchers scale their projects without rebuilding infrastructure every time they develop a new robot or task. NVIDIA also announced that the Isaac GR00T platform will support the Unitree G1 humanoid robot, another popular platform used by robotics researchers and developers worldwide. Several major research institutions are already planning to use the new reference robot, including AI2, ETH Zurich, Stanford Robotics Center, and the Advanced Robotics and Controls Laboratory at UC San Diego. These organizations see the platform as a way to speed up experimentation, improve collaboration, and make advanced humanoid robotics research more accessible. Researchers from these institutions highlighted the importance of open platforms that allow teams to share code, compare results, and test ideas on real hardware. They believe that having a standardized humanoid platform with advanced AI capabilities could significantly accelerate progress toward more capable and useful robots. NVIDIA's own research teams will also use the platform to further develop Isaac GR00T models, frameworks, and hardware technologies. For those interested in getting their hands on one, the NVIDIA Isaac GR00T reference humanoid robot is expected to become available from Unitree in late 2026. NVIDIA also says that the Isaac GR00T workflow for the Unitree G1 robot will soon be available on GitHub and Hugging Face, giving developers even more ways to explore and build the next generation of humanoid robots.